Hello and welcome to the 54th video in this series, Programming a Chess Engine in C. So after the last couple of videos which were fairly intense, this is going to be a much lighter video. We're actually getting very close now to having the program searching, and I just want to do a little bit more preparation to get the program actually searching. I want to add in a new structure, and I'm going to type def struct as normal, and I'm going to call this s_search info. So this will hold information that we need for the search. So we'll have, and I'll go through what they are, we'll have a start time, a stop time, we'll have an int for depth, and we'll have an int for depth set and an int for time set. I'll explain all of these in a moment. And then we'll have a long for the nodes, and I've no doubt that I've missed something, but luckily prepared. I need an int for quit and an int for stopped. An int for stopped. Okay, so let's imagine we're searching. So we call up our think function or whatever it is, search function, and then start our iterative deepening, where we search to depth 1, complete, search to depth 2, complete, search to depth 3, and so on. When we connect to the GUI, we're going to be at the start using the UCI protocol, which I'll show in a later video, and we might actually in this series also implement the Winboard protocol as well, because I find that actually a nice protocol, but I'll explain more about the protocols later. But basically we'll have a time we start searching, and depending on what the protocol tells us, we may have a depth set, which means we only search to a certain depth. We could also have a time set as well. So usually it is a time set, so you've got 5 minutes or something for all of your moves. So we'll take in these parameters into this structure. We'll have one of these structures inside the protocol function and fill these out, and depending on the time remaining, we'll set the appropriate stop time for an appropriate amount of think time. And that reminds me, we also need here moves to go, because we could have a moves to go time control, and we'll also have an int for infinite as well. I'll explain more about time controls and different kinds of things when we start implementing the protocol, but we need all of these here to be able to control how long the engine will think for. So for instance, if infinite is set to true, then we'll never stop the search until the GUI sends a stop command to our engine. This long here of nodes is simply the count of all the positions that the engine visits in the search tree. Quit is exactly what it says on this tin. If we're interrupted during the search and the GUI sends a quit, this will be set to true, and we'll actually do all cleanup and exit right inside the search and close the program. Otherwise, if stop is simply sent to stop searching for whatever reason, say we're in an infinite analysis, then stopped will be set to true, and then we'll simply recursively back straight out of the search without updating any of our scores or results or anything, and maintain our results from the best moves and scores from the previous iteration. So these are the things we'll need to send into our search along with our board. We'll also need to add a couple of other things for the search to our board. And one of those is a history heuristic. So we'll call this, what have I called it here? Search history. And what this is it's indexed by piece type and board square. And essentially every time a move improves on alpha, we'll reset this at the start of the search. This will be reset, all the scores, all the values stored in this array will be set to 0. When a piece or a move beats alpha, for that piece type and its 2 square, we will increment this array by 1. And the other thing we'll have is something called search killers, which store 2 moves indexed by depth. And the killers store the 2 moves that have most recently caused a beta cutoff that aren't captures. Both of these moves here that are stored store non-capture moves only, and these are used for move ordering. I've already said in a previous video that move ordering is critical in alpha beta, and the way we will be ordering our moves generally is, if we find a move that's in our PV table, we'll search that move first. If not, we'll search all captures in what's called a most valuable victim, least valuable attacker order. So we'll search things like pawn times queen before queen times pawn takes pawn. Next we will see if there's a killer that's caused a beta cutoff before in the position. If so, then we'll do that move, and otherwise we'll then search in the order of the history moves. And these will be used to set the scores in the move generator, which is why they're inside the position structure, the board structure, so that we can access these when we're generating our moves. And you'll see more about how these work when we start writing the search. So that's it for this video. That's all the setup we need actually to get searching and storing, I think, basically most of the information we need. For the next video I'm not sure which direction to take, whether to start implementing the protocols to the GUI and then doing the search, or to start putting the search in and then the protocol to the GUI. So I'm not sure what we'll have in the next video, but until the next time, thanks very much for watching. Comments, questions, criticisms welcome as always on YouTube.